Hey everybody, welcome to the Single Tracks podcast. My name is Jeff, and today my guest is Tom Place. Tom is the co-owner and head of product development for Outbound Lighting. He's a former Cree LED manager and holds multiple LED chip design patents. Thanks for joining us, Tom.
Yeah, happy to be here.
So tell us a little bit about your professional background. Sounds like you've been working with lights and LEDs for a while now.
Yeah, I mean, I grew up with a lot of lighting in my life because my dad did a lot of daylighting research as a professor, but professionally started in 2011 at Cree, major LED manufacturer in Durham, North Carolina, where I worked in the LED chip design and fabrication side of the business, and then moved into running our global applications engineering team, where we had a lab where we basically took in, new products from big customers, GE, Panasonic, and so on, that were kind of pushing the envelope with either new optical technology or new construction methods, and they'd run into issues. So they would send it to us to basically put it through testing and figure out what we could do to improve it. And so we would take it, measure it, make some modifications, remeasure it, and then send the results back and basically give them guidance on, all right, if you use this different LED package design, or if you use this thermal interface material or this optic construction, we can improve XYZ by whatever percent. And it was cool because it really gave me a lot of insight into the whole systems engineering approach, where it's not just an LED and an optic. There's, the thermal interface material, the PCB stack up, electrical noise from parts of the circuit, the sealing of the total package, and got to see a lot of really unique problems, which I think sets me up pretty well to, not run into those same problems in my own design process, tribal knowledge. And then from there, had an opportunity to get into bike lights and kind of jumped on it because the rest of my personal time and livelihood is tied to riding a bike.
Yeah. Interesting. Yeah. I mean, it sounds like you have a real technical background and understanding of lights. And Cree, I mean, that's kind of the biggest name in LEDs for a lot of applications, and especially bike lights, right? Like a lot of bike light companies are using those Cree bulbs and LEDs in their designs, right?
Yeah, and Cree really made a name for itself in the portable lighting market, because some of the sales guys way back in the day would get on like candle power forums and stuff and talk about the LEDs. And for the start of the company, they had a big leg up on everybody else because they used silicon carbide to grow their epi for their LEDs, and it was significantly more efficient than sapphire as a growth substrate. So people don't need to know all this. At any rate, they're about 20% more efficient than anybody else in the market for many, many years. And so other companies like Nichia and Osram couldn't compete because they just weren't efficient enough because they didn't have a silicon carbide substrate to start with. Now everything's kind of at parity, so it's more an application-based thing where cost and size come into it more than just raw efficiency. But they pretty much every portable lighting device you pick up is, up until the past 2 or 3 years, has been almost entirely Cree or fake Cree parts from random.
Interesting. Yeah. I mean, they certainly have built like a brand name to people who dig in even just a little bit, right? Sort of like computers back in the day, like the Intel part. And so, yeah, when people are buying a bike light, I mean, a lot of the bike light companies, they advertise that as like, we use Cree bulbs. Which is interesting. Yeah.
And they have to actually vet that to prove that they are using Cree LEDs, genuine product, in order to be able to put that label on the box. Because they've had some products before. I mentioned the fake LEDs, where this company called Lattice was making clone parts that looked identical and then selling them to these flashlight companies so they could pay less, but still say Cree LEDs and sell that way. So there's always something.
Interesting. So, I mean, obviously LEDs are used in a number of applications and different products. So for you personally, like you mentioned, you're interested in mountain biking, but like, seriously, why mountain bike lights? Like, isn't night riding sort of like a niche within a niche? Like it's not a huge market compared to like other things.
No, but it's also one that has not had a lot of focus on it. There's opportunity to make something better here. So me personally, it was a natural fit because it's my two biggest passions in life. And so if I can make those work professionally, then absolutely I want to do that. But my partner, Matt, who's the founder of Outbound, he's the one who actually started this. And the reason he did is because he's an automotive guy. He races rally cars and used to work for Diode Dynamics and knows automotive lighting really well. Went for a trail ride with a buddy of his, and his buddy gave him a couple of, I think they were Night Rider lights at the time, and went out for a ride. And he was like, really? This is the best the industry has to offer? And this cost how much? What?
Yeah.
And he thought, I could do something better at a more reasonable price. And he did. So I reached out to him because he was actually doing something novel with the optical design and not just, making another flashlight that was rebranded. He was doing something different. And I thought we could do some pretty cool stuff together.
Yeah, interesting. Well, yeah, I mean, thinking about that, the different applications, and I mean, you mentioned like your partner came from the automotive world where I imagine you want your lights to, your beam pattern to be a specific shape, and, you have certain things you're looking for at night. Like, what's the ideal beam shape then for trail riding? And then, like, how is it different from maybe other things people might be trying to light up?
Sure. And it's all application dependent, right? So like the light bulb in your house is good for lighting up your room because it's omnidirectional. It's just casting light in all directions and it's not focused. You try to use that on the trail, you'll blind yourself and you won't be able to see very far because it's not focused anywhere. Mm-hmm. On the other hand, if you take a really narrow beam, like a searchlight that people use out in the woods that projects 3 miles, now you can see that one tiny spot really well, and you can't see anything else. So that's not good either. And this is where, bike lights to date haven't really, with a few exceptions, haven't really put focus on optimizing that beam shape for the intended task. So for trail riding, it kind of comes down to where the light is going to be mounted as well. It's not just one beam shape for everything. I would say that in general, for a handlebar light, you aren't always turning the bars where you need to be looking. If you're counter steering into a corner or just on a technical climb, your bars move around a lot. And if you have a narrow beam light on your bars, the moment you turn just a hair, that beam is now off the trail. So your bright spot is off the trail. So the trail looks darker. And then if you've got, leaves or branches off the side of the trail that are closer to you, now you've got this bright reflection off of that. So you're getting this kind of flashing effect, and it makes it harder to find the trail. So for bar light, we think it's just a lot better to have a really wide beam side to side. And then because we know that handlebars on bikes are going to be roughly the same distance from the ground, it's suspension dependent, but it's going to be about 3 feet or so. We can tie that into our simulation, our design, so that when your light is mounted that height, pointing straight out, you get a nice even covering on the ground in front of you, because you don't want a hot spot right in front of your wheel. You also don't want it to be dark. You want to be able to see that out of your periphery. So having something that's really wide and even, I think, is important on the bars, whether it's ours or somebody else's. And then with a helmet light, you can get away with a bit narrower beam because you're pointing your helmet where you're looking. So you don't need to have the entire field of view covered because you're controlling it much more directly. Still, though, having something that has a gentle fall off or a smooth gradient from the spot in the center to the edges is important, mainly so that you don't have as many distractions on the trail. Because if you're riding, you want to be focusing on the feature in front of you, not positioning this perfectly shaped circle of light right where you need it to be. You want to just focus on the riding. And if you have this circle or a hard edge or any weird beam artifacts, that tends to be distracting, and it gets in your head, and that's not great.
Yeah. Does like the trail itself kind of dictate that too? I mean, I'm thinking, where I ride, there's thick forests and you've got a lot of trees and things that are like right in your periphery versus riding somewhere like the desert, let's say, where it's like really open. Like, do those both kind of need the same beam pattern, or would there maybe be a different need there?
It's entirely, so I found when I was talking to somebody about this the other day, I say it depends a lot because it's all,
because it does. This is the world we live in. Like,
yeah, like the marketing side of me wants to say, no, this is the perfect answer for that. But
yeah.
all of this depends. So to your point though, like I used to live in the Phoenix Valley in the desert, and oftentimes I would ride with just a handlebar light for two reasons. One, because the trails were all just sharp rocks. It was really rough. So the handlebar light gives you depth that you don't get from a helmet light because it's mounted lower. So it casts shadows out that you can look down into. So that rock sticking out of the ground looks like it's actually sticking out of the ground and doesn't look flat. Helmet lights by themselves make trails look very flat because the light's above your eye line. But the desert also is very wide and open. It doesn't have trees. You know, there's cacti, but there's not trees and branches and leaves covering every corner. So with a wide beam on the handlebars, even if it's a tight switchback, I can still see it extremely well because there's nothing. So you can get away without a helmet light. On the other hand, you know, like I'm in Pacific Northwest, it's going to be very similar to the type of riding you have. If you're in thick forest, a lot of those switchbacks are covered, and handlebar light by itself doesn't always cut it. There's still a lot of value in the handlebar light, but supplementing with a helmet light helps. And then the other extreme of that actually would be people like I was talking to Clay Harper at the US Open, Fox US Open. He goes out with his son and they hit like 30-foot booters at night. And for that, handlebar light doesn't really do you much of any good because you're going up in the air and your bike is not pointed at the landing.
Right. Also,
those, you know, jumps tend to be really smooth and buff. You don't need to read three-dimensional terrain because you know the takeoff's going to be smooth, right? So for doing jumps, like helmet light by itself is the way to go because you really need to spot up your landings and you're not having to read rough terrain as much. So it's really horses for courses.
Yeah, interesting. So yeah, I mean, you kind of hit a number of the questions that I had in terms of like the light placement and how that affects the beam shape. And, you know, it sounds like too, I was going to ask you, you know, if you only had one light, would you rather mount it on the bars or the helmet? But clearly you're going to say it depends because it truly does. And I understand now though, like why it depends. And yeah, those are great examples. Like, you know, I was thinking about like really steep trails, and that's kind of that same example with the, you know, riding jumps at night where a helmet mounted light's going to be best for that. Whereas maybe if you're in a more open area, you can get away with bar lights. So yeah, I guess it just depends.
Yeah. And that steep example is like all of my trails around here are steep. You know, you roll up to an edge and you drop into something, into a chute, into whatever. And you're right. Leading up to that, the bar light tells you, hey, there's something steep coming up, but it doesn't tell you what's in it.
Yeah.
The helmet light helps see down into it. But then once you're into it, having the handlebar light helps. So it's not just a, you know, there's some, you know, like jump lines, maybe the one example where a helmet light by itself is always best. But on most trails, having both is usually the right answer.
Yeah.
If you're going to only have one to start with, yeah, it definitely depends on your use case. If you're living out in the desert, absolutely, I'd say handlebar light first. Just get a really wide beam pattern and start with that. If your local trails are straight line, like basically World Cup downhill courses where you're hitting 40 miles an hour, then yeah, maybe helmet light first is a good place to start. But
yeah, I mean, because a lot of people, when they start out night riding, obviously, you know, it's something that you don't know until you've tried it, like if you're going to do it a bunch. And so, yeah, I mean, rightfully people are like not going to make a huge investment. Most people that I know start with just a single light. And it is interesting that I feel like a lot of the lights previously on the market, they weren't designed like specifically for a helmet or specifically for a bar. So a lot of people would buy a light that they say, well, I could put it on my helmet or my bar, just depending on what I figure out, you know, in these first night rides. But yeah, it sounds like it's pretty crucial to have kind of a different setup for that beam pattern, depending where you're going to mount it.
Exactly. And that's really why we saw this opportunity in the market to begin with is we're not making a generic bike light that can be mounted anywhere. You could take our bar light and mount it on your helmet It's not going to be great. Beam's going to be really wide. It's going to be a lot heavier because we're using more power for covering a larger area. So we have to have a larger battery and so forth and so on. It's not optimized for a helmet.
Yeah.
But our helmet light is. And we basically design the bar and the helmet light beam patterns to work together so that you're not seeing two distinctly different things, but you're just kind of seeing everything lit up evenly. I'd say for people just looking to try it out, you're absolutely right. You know, people don't want to spend a lot of money if they don't know they're going to like it and not going to get into it. But I would say, remember when you first started mountain biking, as most people didn't start with a $6,000 pivot or something like that. They started with a cheap bike. And then when they graduate and get nicer equipment as they ride more, like, oh, turns out it is worth paying more for performance in my suspension and my wheels and dropper post, whatever. It's kind of the same way with lights. If you just get a very narrow beam, dim handlebar light and you stick it on your bars and you go night riding, you're probably not going to be able to see very well. And it might be kind of a crap experience the first time. So maybe you would want to do it again. But doesn't mean that you need to go buy the most expensive light off the start. Just keep that in mind when you try it out so that you don't just say, oh, well, obviously I don't like night riding because I can't see anything. It's like, well, you can, but you may not start that way, and that's fine.
Yeah. Yeah. And I'm always trying to get people to join me night riding anyway. And so I'll keep around, some extra sets of lights and let people try it out. Because for sure, it's different. It's not for everybody, but I think it's a lot of fun.
It is. And doing it with groups is a lot of fun. It's always a mess when you've got, 10 different lights all shaking and pointing around. You get shadows and flashes from all over.
Yeah.
That's totally different from night riding by yourself or, with a gap between riders because your illumination changes quite a bit. But group rides are always the best way to do night rides, I think.
Yeah, for sure. So I want to talk about lumen numbers. This is a number that a lot of buyers have been sort of trained to look for. It's almost like, I don't know, back in the day when you buy a computer, you're like, how fast is the processor? And like, how much RAM does this thing have? And, people look at lumens. That's one of those numbers that's like kind of front and center in a lot of marketing. So is that a good number to focus on?
Yes and no. It is a number that has value and tells you something, but it only tells you one thing. And that's the total amount of light that comes out of the product. It doesn't tell you anything about where the light's going, how much power it uses, what the runtime is, the weight, none of that. And it's kind of like, my partner's a rally guy, so I'll use the car analogy. It's kind of like buying a car solely based on how much horsepower it has. Like, a semi truck has like 2,000 horsepower, could be good, or like 600 horsepower, like 2,000 pound-feet of torque, but it's going to be slower than my Honda Civic with 150 horsepower.
Right.
Also, if you don't have good tires and good suspension, then you're not going to put all that power to the ground. You're just going to do burnouts and make a lot of smoke, and it's going to look cool, but it's not actually going to go very fast. So there's a lot more that goes into, having a fast car than just horsepower. In the same way here, you can have a really bright, in air quotes, light, and it's not actually better for your visibility for seeing the trail. So a lot of that comes into beam pattern, which can't be conveyed by a single number like that. But it's also, you're right. It's what people have been trained to use because it's the only metric we've had in the industry for many years. You'll see in Europe, they started using intensity rather than total output. So they use lux instead of lumens. So lux is referring to basically the number of lumens that are hitting a certain spot in the beam pattern. So your peak intensity is the brightest spot anywhere in your beam, and they'll rate that with lux. And that gives you a better idea of, like the throw of the light and how focused it is, but it still doesn't tell you about the beam shape at all. So it's kind of tough to say, oh, you just got to go look at the shape for the trail and see what's best, because it's hard to convey that. Also, you can get beam shots, but if you point it at a wall in front of you, or if the shot is on a wall, it's a two-dimensional object. That's not what your trail looks like. So it doesn't really tell you what it's going to look like on the trail. Honestly, the best way is if you can go get into a shop or, friends who have the lights and actually test them out in the woods and see what the difference is. That's the best way to kind of really see the proof in the pudding. As far as lumens go, though, your eye doesn't respond linearly to lumens either. So somebody says, oh, I've got a light that's twice as bright as this one. Yeah, it's got twice the lumens, but your eye doesn't see that. It really takes almost 4 times as much light for your eye for it to feel twice as bright. Yeah. There's a lot of factors in that, but it's because it's not an electronic sensor. Your eye is chemical receptors, and you have a pupil that is, opening and closing. You have an aperture that's controlling the amount of light coming to your eye. So if you stand outside in the midday sun, your pupil will constrict and let less light in to protect your eyes. When you go into a dark room after being out in the sun, you can't see anything because your eye is very slowly adapting to the darkness, and it takes a while for your pupil to dilate and let more light in. So when you go from let's say 1,000 lumen light to a 2,000 lumen light, what happens is, you've got twice as much light, but your pupil also constricts a little bit to react to that, because now you've got a brighter, more intense spot, and your eye is protecting you, letting less light in. So it doesn't feel twice as bright. And that's where, it's not that important really to have 8,000 lumens on your bike. What that means is that you have to have a much bigger heat sink on the light, which makes it a bulkier product, and means you have to have a much bigger battery to be able to maintain that output for any reasonable amount of time. And very quickly you go from something that's really optimized for putting on a bike or putting on your helmet to something not optimized for that, but super bright. And some people like that. I kind of equate it to doing a burnout. It's like, yeah, that looks cool. I'm gonna drive past you now.
Burnout for your eyes. Yeah. Well, so, I mean, it seems like what some of these, super high lumen lights are doing perhaps is, can you make up for the beam pattern with a really bright light? Like, could you just have kind of junky optics, but it's fine as long as you have like a ton of light and it's just pumping out everywhere?
Not really. In fact, you can make it worse by doing that. If you, in that example, if you have a really like wide beam, like just really diffuse light where it's not focused into a spot, then yes, having more power makes up for that a little bit. But it also means that your foreground, what's closer to you, is going to be really bright, and cranking up the brightness just makes that brighter, but it doesn't project down the trail at all. So what you'll find is that you'll focus on the light on everything lit up really well in front of you, but you won't be able to see the run out on trails. And so it compensates a little bit for intensity on certain spots, but it does not give you the real better visibility on the entire field of view. It doesn't help you read the trail better.
Interesting.
And if you have if you have a really narrow beam, cranking up the brightness doesn't do anything except make that spot more visible and everything else look darker. So it makes it harder to see anything else around you if you just pile more lumens into one spot. Yeah,
that makes sense. Well, so if we can't really rely on lumens, like you said, it's sort of helpful, but it doesn't tell the whole picture. It sounds like lux is maybe possibly another thing to look at, but is there something else that you could look at to compare lights, or is it really just you got to try them and see how they work for you?
Trying them is always best, but I know that's difficult. Really websites it's hard to convey all this information because it's not just singular data points, and there's not a really standard method for doing that. Like commercial lighting, they have, they'll take slices of a beam pattern, for like a can light in your kitchen. They'll measure it in a, horizontal slice, and then they'll do another slice at 90 degrees, and they'll basically publish a little chart showing you what the intensity plot would look like. No bike lights do that. None of them. So no manufacturers, rather. Even we don't do that right now. And it's mainly because there's nothing to compare it to. You can look at ours and not really know what that means. But we do have we try to take accurate trail images where, with the slider, so you can see the difference in the general spread and hot spots and color separation. And there's a lot of, not a lot, but there's a few third-party sites as well that, will do beam comparisons and, light shootouts and stuff like that. They're not always perfect, but if you can get, something that's actually showing a beam shot, on the trail, then you can get a better idea of like, oh, that is a pretty narrow beam. I can't see anything around, my front wheel there. And, maybe that's not something you realize as important, but if you're on a pretty technical trail and you're trying to place your front wheel in the right spot and you have to look down with your helmet light to see where the wheel's going, then that's not good. So that affects your night vision, and your balance is not how you ride during the day. You can normally see that out of your periphery, when the entire trail is lit up in daytime. So having that peripheral spill matters, and you can see that in beam patterns where, a light has a reflector, and so it's got a really harsh circular cutoff in the beam, and everything outside of that circle is dark. That lets you know that, you're not going to see any of that in the real world. But we're trying to get in more local shops too, so that you can, pick stuff up and play with them. That's a good place to start, with any brand that's out there. Just go into your shop and ask to turn stuff on. Pointing at a wall isn't the best test, but if you can get into a dark supply closet even and just turn it on and see what the scatter looks like, what, more than just the main spot, that'll help.
Yeah. Yeah. The shots that you're mentioning, on the Outbound website where you can see sort of the beam compared to another one, same spot in the trail. It's really helpful, and it is pretty dramatic, the difference that just that beam pattern, beam shape can make in terms of lighting up the trail. Yeah.
And there's a lot of work that goes into that. And to date, and really for most lighting manufacturers, the optics are pulled off the shelf. It's fairly uncommon for them to make their own optics because there's already much larger industries. To your point at the beginning of this is a pretty niche industry. Lights for bike riding, particularly for trail riding. So pulling stuff off the shelf is never going to be optimized for the trail because the market isn't there. So we're trying to basically create that with our own in-house optical designs, and that's not cheap or easy, but I think it makes a big enough difference that it's worth doing.
Yeah. So most bike lights that we're familiar with tend to have like 3-ish brightness modes that you can kind of cycle through. What's the purpose of that? Is it just for speed? Like if you're going really fast, you want the brightest, and then if you're going really slow, you can do the lowest, or is there something else going on? Is there another way we should be using those brightness modes?
I've had a similar discussion with a couple of customers who are adamant that we need to change our user interface to be something specific, either mode memory or only 2 modes, or they need 5 modes for some reason. And it kind of speaks back to personal preference. I mean, a lot of it is going to be how you use the light. And I'll tell you kind of how we've approached that and why. For the most part, it's so that you can control your output for the type of riding you're going to be doing. If you're going to be doing a longer ride where you're not going to be moving as fast, then you want to get more time, then you can put it on lower output and survive the ride. But for us, we wanted to cover the 2 main use cases for trail riding, being kind of the set it and forget it cross country crowd and more enduro style rides. So for the cross country crowd, that's maybe not the best catch-all term, but basically a ride where you're going to be averaging a decent clip and pedaling and moving kind of up and down. There's not like a long, slow climb in the middle of it. You're moving the whole time. You just don't want to mess with the light output constantly. Then we have an adaptive mode that basically starts at max output and slowly tapers as your eyes adjust to the darkness so that you don't feel the change in light, but you can get longer runtime. And that's we have it always turn on in that mode to start because that's what that crowd would do. They turn it on and then never touch it again. They're not thinking about runtime. They're not thinking about modes. Just want to go and ride. Yeah. And then we have a, dedicated low and high because that's what the enduro crowd needs, where you've got a climb where you're going 3 miles an hour for the next 45 minutes, but then you've got a 10-minute descent where you need max output because you're going to be going, 30 miles an hour, whatever. You want to see all the rocks in that rock garden.
Mm-hmm.
And so you can put it on low for the climb, use very little power because you only need to see, 20 feet in front of you. And then for the descent, you crank it up to high, and then high maintains 100% output so that it always is max no matter what your battery is doing. So I think for most lights in general, it's the way to think about it, I'd say, for your particular use case as a rider is just what kind of rides you're going to be doing. If you're going to be doing rides that have long, slow climbs, turn your light down for them because you'll get more runtime out of it. And the other benefit is that your eyes now adjusting to less light in front of you.
Yeah.
So you turn the light back up, your eyes have adjusted to less light. So the brightness will feel even brighter the next time you crank up the mode. So that sometimes helps with visibility at the start of a, rowdy downhill.
Yeah, that makes a lot of sense too. I mean, that's how we look at suspension a lot of times too, right? Like you've got a climb mode, you've got a descend mode, and then, I guess the adaptive mode is more like a pedal mode where you're, like you said, you're moving at kind of a constant speed and you want to just keep going and not have to worry about it. And that's a really good trick too, like adapting the amount of light, because like you said, your eyes kind of adjust to it. And if you can do that without the rider noticing, it seems like you can get a ton of extra battery life out of that.
Yeah, that's actually a great way to think about it. The climb, trail, descend, the old Fox CTD shot.
I was going to say that, but I thought that might date me or something. But yeah.
It dates both of us now.
Yeah. Yeah. So let's talk a little bit about the batteries. How do you determine the optimal battery size for a bike light? Is there like a ride time that you're shooting for? I mean, it seems like most lights tend to offer kind of the same amount of battery life, but like what's, as an engineer, as a product designer, like what's kind of your take on that?
Yeah. So a lot of factors go into it. First and foremost, it's the packaging. So we're making all self-contained lights because we don't like having external battery packs, at least not being forced into using an external battery.
The wires and where do you put stuff and
how do you mount it to your frame without scratching it or whatever. So with that means we can't just pack giant batteries in there because then you have a big bulky light that nobody wants. So a lot of that comes down to the cell size and shape and then the efficiency of those cells. So right now there's basically only two cell sizes on the market that make any sense to use. It's an 18650 and a 21700 that are both lithium ion cylindrical cells and pretty much what everybody uses with a few exceptions. And that means if you got a cylinder that's 21 millimeters in diameter and 70 millimeters long, you can only fit but so many of those in certain arrangements. You can't just pack them flat like lithium polymer cell. So fitting that in the housing is step one. And second most important thing is how much light do you actually need for that specific product, for where it's going to be mounted, and then what kind of runtime do you want? So we try to shoot for at least 2 hours in our adaptive mode because that covers most people, not everybody, because it's impossible to make a product that does everything that everybody wants. But most people are night riding local trails because they're not traveling to, some exotic location to ride at night. They're going there to ride during the day.
I always tell myself I am. Like, I have these trips, I'm like going somewhere. And I'm like, all right, I'm going to bring my lights because I'm going to do a night ride while I'm there. And then I never do. I get too tired riding during the day.
Exactly. Yeah, we run into that in the Sedona Mountain Bike Festival, too, because we do a demo ride there on the Friday night of the festival every year. And we get a lot of people that come up to us at like 4 p.m. and say, I think I'm going to skip it because I've been riding all day and I just started drinking beer. So I'll see you guys tomorrow. Like, right. That's fine. At any rate, we basically are back calculating how much battery capacity we need for how much light output we need for a given amount of time, right? So the handlebar light, because we want a wider beam, that means we're covering a larger area of the field of view. So we need more light to do that, which means we need a larger battery to get the appropriate runtime. So we're basically, we do the same thing with the optics where we're figuring out the intensity distribution we want on the trail, and then back calculating how many lumens it takes to produce that beam at that intensity.
Okay.
So that all directly weighs into what type of batteries we use and how big they are.
Interesting. So one of the things that LEDs, there was this shift. It's been a while now. And again, I will date myself, but, a while back there was another technology that was used for the bulbs and for lights. I think it was called HID. And one of the problems with that, or, the big inefficiency with that was that these bulbs were like really hot. Like they produced a ton of waste heat. But LEDs seem to have the same problem, right? Like I'm reading a lot of stuff about, and you've mentioned it, heat management and all of that with LEDs. Why do they produce so much waste heat? And like, is there something better on the horizon than LEDs?
Great question. So, no, there's not something better than LEDs, but LEDs are still getting better. The inefficiency comes down to just the raw efficiency of converting electrical energy to photons and photons of a certain wavelength. So it's not just blue, it's a broad spectrum white, and it gives you color rendering that you can actually see differences in different colors. So essentially what you're doing is you're pumping electrons into this LED chip that's producing blue light that is now hitting a yellow phosphor, which is then converting that blue photons into a broad spectrum of different wavelengths, longer wavelengths. So you can get the mix between the blue and the broad yellow to make a white light. So every step of that has an efficiency loss. The LED itself converting blue photons, and then the phosphor, and all of it, if it's inefficient, it's producing heat. So, the example you mentioned with HID, or, maybe a simpler one is with incandescent bulbs, in your house.
Yeah.
Incandescent bulbs are cheap. They're just a filament that you're running enough power through to heat up to the point that it's glowing red hot. Those are incredibly inefficient. So in terms of lumens per watt, you might be at best 15 lumens per watt, but most are like 10.
Yeah.
LEDs, we've gotten, the record-breaking LED that actually helped with at Cree was 303 lumens per watt at the time.
Wow.
So 30 times more efficient than that light bulb, the incandescent bulb. But under 100 lumens per watt has been a pretty good benchmark for an efficient light source these days. However, the theoretical maximum conversion efficiency you can have for photons produced at 555 nanometers is going to be 500 something plus lumens per watt. So that means if you're at 100 lumens per watt, that 80% of that energy is still waste. Technically speaking, it doesn't quite relate that way because of how your eye responds to, red, green, blue peaks and all that. But point is, there's still a lot of inefficiency, and it's just less than older technologies. So that means you have to manage the heat coming out of it. And if you don't do that effectively, or if you're trying to pump out, say, 8,000 lumens in a very small heat sink area, you either need a massive heat sink or you need a lot of airflow to do that. And so what happens a lot is you'll see thermal controls where the light, this light gets 2,500 lumens, and then 7 minutes into runtime, you're at 1,500 because it's too hot. And what we realize is that it's not the LEDs, we can actually push really hot. It's not the LEDs that are going to die or anything like that. It's touch temperature. If you touch your light and it burns your hand, that's a problem. So we're actually controlling the case temperature with our thermal controls and letting the LEDs run a little bit hotter. And so what we can do there is basically push out our thermal controls so that you don't have that immediate drop off where the light is now screaming hot and you have to pull back the power in order to get it to cool down. We're basically trying to give you just enough thermal capacity so that if you're moving at all, 2 miles an hour, the light will stay cool and be fine. Yeah, it'll get warm, but it's not going to get hot enough to burn you.
Yeah. Yeah. I mean, the light bulb example is actually what got me thinking about this, where, if you have a incandescent bulb in your house, and you need to take it out of the socket while it's on, like you can't touch that. It'll burn your hand. But with a LED bulb, like those are not even hot to the touch. And so why is it that bike lights are that much hotter? Are they that much brighter? Are they in like a smaller space? Like what is it that they are really like heat sensitive compared to like what we're used to in our houses?
Yeah. I would say that some LED bulbs in the house do get screaming lava hot. But that also comes down to, they're designed for they have enough thermal mass and heat sink to not have airflow, right? Because a bulb inside a lamp doesn't have airflow to cool it down. Bikes do. However, if you stop and your light is still on high and you're farting around with your derailleur adjustment or something in the middle of the trail, yeah, your light's going to heat up because there's no airflow. And we're trying to balance, we could make more thermal mass so that it's perfectly stable in all conditions and it equalizes, but then you have a heavy, bulky, unoptimized product. So it's really comes down to bike lights are trying to push more power out of something small. And they don't want to make something big and ugly. Yeah, makes sense. Lots of trade-offs, lots of considerations that dictate that design for sure. And obviously a lot of thought goes into that. While we're talking about heat, so I'm curious to know, in the past there's been reports, maybe rumors of like bike lights causing problems, catching on fire and things like that. What would cause a poorly designed or manufactured light to pose a safety risk? Is it the light? Like, is it the bulb overheating? Is it the battery? Like, what is it that people need to watch out for? That can maybe give them a clue that like something's unsafe about a light. So people shouldn't have to watch out for any of that. Like the properly designed product does not have the ability to burn your house down. That's actually something we think about in our optic design too. The benefit of our designs where we're spreading out, having a much larger optic area is that we're basically running less light through it's less light density. So rather than pumping 2000 lumens through a 1 inch circle, we've now spread it out to a much larger area. So if you turn your light on high and stick it in a bag of like black cloths or gym clothes, it will not start the bag on fire. We actually tested this by taking 100 Evos in a box and turning on 20 of them in the box and just seeing what would happen. Box gets very warm, but it doesn't start things on fire.
You didn't lose 100 Evos. That's good too. You must have been pretty confident.
Yeah. Well, there's another longer story behind that, but I would say that the two ways that things can go wrong at home are the lens, melting something by being pressed against something in high output mode, and then the batteries catching fire. Neither of those are legitimate. Like they're not legitimate. Neither of those are real concerns with products today. You get something from Knight Rider or Light in Motion. They have like lockout modes to prevent you from accidentally activating them in a bag. If you take a very high power bike light and you turn it on max power and you stick it down on the black vinyl on your car seat, you might melt it. Don't do that. Ask me how I know. And then for the batteries, every legitimate manufacturer that's out there is using quality cells, from Samsung or LG, or they're not using garbage stuff from China. Stuff you get on like Amazon for $40. That's where all these horror stories come from. It's from batteries that are charged with chargers that don't have any regulation. They're just putting out voltage. And so they don't have any intelligence in them to say, okay, I'm overcharging, or I'm pushing too much current, or there's something wrong.
Yeah. They're not talking to the battery, like getting feedback from the battery itself.
Yeah. It's just pushing power towards it. And, with cheaply made stuff, you get people cutting corners, and what happens? You get solder joints that fail. You get, insulation that gets worn through, and, bridges and shorts in various places, and you get cells that are just bad because they're not using quality cells. And so the reports of like a bike light catching fire and burning someone's garage down, there are credible sources that's real, but they're all cheap garbage lights, and pretty much most lights today are USB rechargeable, and it's basically impossible to mischarge a USB device because they have a chip and they're regulating the power coming in.
Interesting.
So you can plug in a 100-watt charger to a light that can only take 5 watts of input power, and the light's going to take 5 watts, not 100. And it's because there's, proper circuitry in there. I have actually witnessed a battery pack catch fire on a ride before out in North Carolina, out in Pisgah. We were doing this night ride, and the guy, put his cheap Amazon Light battery pack into his backpack, and we were riding and started seeing smoke coming out of his pack. And
whoa,
it was the craziest thing I had ever seen. And so yeah, he quickly took that off and dumped the light, unplugged it and tossed it, and it cooled down and it was okay. But it was melting through the pack. It was great.
Whoa. So yeah, I'm hearing stick with the name brands. And also I hadn't heard that USB chargers are potentially much safer, it sounds like. And most bike lights, I think even the cheap ones now, most of those are USB. But yeah, that's good to know.
I say that, and now I'm going to find some, cheap USB rechargeable light that isn't safe. But yeah, everything else has a specific chip in the light that's telling the charger what it can take, and it will not allow more power than that unless something has gone wrong. And it'd be pretty hard for something to go so wrong that the charger itself thinks it's okay still to send more power, but doesn't think something is wrong, if that makes sense. So
yeah. Yep. It makes sense. Cool. So do you have any tips for us about night riding or maybe getting the most out of a bike light on the trail?
Something I see pretty regularly is people trying to figure out how to angle their lights appropriately. And, people with like dual smaller lights on their bars, they'll spread them out and kind of point them in or whatever, or they'll point their helmet light way too far down. And had a guy that said his bar light was just too dim. He was just going to take it off, and it's like pointing up in the air. Like, how about you point that down, like forward towards the trail? It's like, oh, that made a huge difference.
Yeah.
I would say that the helmet angling is where it's really more difficult. The bike's pretty easy to figure out. And a lot of people will angle their lights either too far down or too far up. And what that forces you to do is ride with your head in a really weird position, which affects your riding. During the day, you're not thinking about, you're not trying to position your light pattern where it needs to be because you're not using a light. So your head is just in whatever position it is for your natural riding. And at night, if your light is pointed too far down, now you have to stick your chin up to get your light on the trail. And so you're riding and you can't see as well down low, and you're just kind of in an awkward position. Same way if it's too far up, where you have to look down and kind of look ahead like that. It's just awkward. So I would position your helmet light so that it's pointing down the trail, not right at your front wheel, because it ruins the depth you get from your handlebar light. And, at pretty much everybody you talk to, if you want to go fast, look ahead. Your helmet light's job is to look ahead and then look through corners, tight switchbacks and things like that. So positioning the light so that it's down the trail and not right down in front of you when you're in a natural, whatever your natural riding position is, that's a good place to start. That'll help a lot.
Yeah. So thinking about the handlebar one, because like you said, that one, it is pretty static, like much more so than your helmet lamp. Is there like an ideal angle? Like, could we see like bubble level, like on our lights so we know we got it in the right area? Like, what are we talking? Like 5 degrees down, 10 degrees up? Like what's ideal?
Back to our earlier discussion, it depends.
What does Tom like? What works for you?
Yeah. Across the board, take your light on your bike and just make it level. Point it straight ahead. And then adjust small adjustments from there if you decide you need to. There's, some people prefer to have their handlebar light more down, light up the foreground and the helmet light up. That's fine. I wouldn't point it straight down. I also wouldn't put it too far up. Up basically just wastes all the light. You're not getting any real benefit from that. Down, there is some benefit depending on your type of riding and your personal preference, but I'd start with it level.
Sort of like saddles. I mean, it sounds like, some people like it a little up, some people like it a little down. So if you start in the middle, you should be pretty safe.
Yep. Yeah, that's a good way to think of it.
Cool. And then, any other tips for getting the most out of biking at night, or any inspiration you have for people who are thinking about getting into night riding?
I'd say just, first of all, just go do it. Find some buddies with some lights like yourself and borrow their lights and get out and try it. And just recall that, your first experience mountain biking maybe wasn't great. And you learned a lot from it, and it's now better. Same way with night riding. There's always things you can be doing to improve your setup and improve your mindset. If you're going out chasing KOMs on Strava, then maybe don't do that in general, but don't start night riding by doing that. And don't get upset if you're going slow because you can't see as well. Figure out why you can't see as well and address that. Sometimes I would say that for the average person, night riding is a necessity. They live in an area where it gets dark after work. And so for half the year to ride, kind of have to ride in the dark or just on weekends or whatever. But a lot of people get very different experience out of it. And it's not, having the best lighting setup isn't necessarily the thing that makes it the best. So I like just riding at night. I test a lot of stuff, but I also like being able to see really well because I like riding my same gnarly trails the same way I do during the day. But some people just enjoy the fact that they're riding a trail where they can't see as well. So they'll use a smaller light or specifically use a narrow beam light where they can only see the thing they're looking at because it's more exciting, because it's different.
It feels a lot faster in a lot of ways. Yeah.
Yeah. It's not necessarily a bad thing. It's just different. So, you can get away with not having a supremely dialed setup, if you've got the right mindset for it. And to that end, night riding is a good way for people to see things differently. Your trails look different during the day. If the sun is straight up ahead, or if it's at, just at dusk on the horizon, the trail gets lit up very differently. And then as you're going through a winding, twisting trail, depending on where the sun is around you, that trail is being lit up differently. At night, the lighting is extremely consistent. It's always in the same spot on you where you're going, but it is never the way it is during the day. So it looks, the way you read that drop feature or this section of trail, you may see a line that you never saw before because of just the way it's lit. And I think that's a good thing to keep in mind when you're night riding, is not just trying to, getting something different out of the experience, right? Freshening up those local trails. And then maybe you go back during the day and realize, oh, I could do this in this section, and I never really thought of it before, but it like jumped out at me at night. That happens a lot with people we ride, where we take, let's call them alternate lines, and sometimes they work, sometimes they don't, but it keeps things fresh.
Yeah. Well, that's great advice and inspiration, and ton of knowledge about bike lights that's super helpful for those of us who ride at night. So thank you. Well, we'll have a link to the Outbound Lighting website in the show notes, where you can check out some of those photos we were talking about, showing beam patterns, and you can also find a little bit more information about bike lights and how they work. So we've got this week. Talk to you again next week.